Welcome to an episode of JSearch using Facets. This video is an episode in our JSearch series and will cover what facets are and how to create them. Given the code involved, this tutorial is intended for developers with a familiarity with MarkLogic. Additional details about these concepts can be found at docs.marklogic.com. In this tutorial, we will introduce you to the concept of facets, show some examples of creating facets, and finally go over how facet results can be adjusted through the use of pipelines. The code examples and source data used in this tutorial are available for download from MarkLogic University's GitHub site. Think about almost every search application you use. On the left-hand side will be a means of filtering the search results. These are facets. They allow us to drill down into our search results. In MarkLogic, these facets are based on range indexes and lexicons. So this means that for each facet you wish to create, you would need a range index or lexicon to base it on. For more information on this, please see the administrator's guide at docs.marklogic.com. The two main interfaces for creating facets are the JSearch Facets and Facet methods. First, you create facet definitions using the Facet method. You then pass those definitions to the Facets method to create a facet generation operation. Facets are not actually going to be generated until you call the result method. For each facet that we want to create, we need to specify a JSearch facet. The Facet method will take two arguments, a label for the facet and the name of a range index or lexicon. The label will become the property name for the facet data in the results. For example, this line of code defines a facet based on the range index format and will be labeled as media type. Those facets need to be passed to JSearch Facets method. To restrict the documents which are being used for the facets, you can pass one or more CTS query objects to a where method. Remember, it is the result method that will actually generate the facets for us. Now, let's run this and see the results. By default, only facet data is returned from the facet request. Here we have our facets object. In the object, each facet will be listed using the label from the facet method, with the value being the match count for each entry in the facet. Notice that all we have is the facet data. What if we wanted to get snippets, complete documents, or document projections? All that would be needed would be to include a documents query in your facets call. As you can see, we now have both the facet details and the document search results. We can take that simple facet request and customize it using a pipeline pattern. These pipeline stages are optional, but must be used in this specific order. Most stages behave as they do when used with the values query and were covered in the Intro to JSearch tutorial earlier in this series. Others where and this where control how facets interact with each other and with any queries that are part of the facet call. Group into can be used to create bucket constraints. The results can be sorted using the order by method. If you only want a portion of the results, you can use the slice method to set the criteria. The map or reduce methods can be used to apply transformations to the result. Please note that you can only use one or the other, map or reduce. You cannot use them both in the same call. Advanced options can be specified using the with options method. Let's look at how a few of these are implemented with regards to facets. The JSearch Others Where feature allows for multi-facet interactions. This means we can vary facet values across user interactions and deliver a more intuitive navigation experience. This will apply criteria asymmetrically to the facets and collectively to the document search portion. Here you can see we have two facets that are applying others where to selection criteria based on itself. Since we are using others where on each facet definition, each facet is unaffected by the other, but the document selection is affected by both. This makes it easy to see and select alternative criteria. If we move that logic into the where method, the behavior changes. Now, we can't readily see the other facet options, such as author now being reduced to one entry. Group into can be used to create buckets of values based on value ranges. Let's say we want to group our documents based on price. You could use a facet definition like this. One or more buckets need to be defined within the group into method. Each bucket will have a bucket name and a bounding value. The first bucket will be anything up to that value. Subsequent buckets will range from the previous value to this bucket's value. Notice that the last bucket does not have a value. This is because there is no upper limit on it. So with this example, we will have 4 buckets created. For each of the generated facets, we will know the boundaries of its bucket, the highest and lowest value, and the number of documents that fell within the given range. In this video, you learned about facets. You saw how to generate facets and how the generation of facets could be affected by pipelines. Thank you for attending this MarkLogic University on-demand course. Please visit mlu.marklogic.com/on-demand for a complete selection of on-demand topics.